Good morning. This is a video for those who missed on the day that we were talking about proportional relationships. Or you could also use this as a way to study for the test on Friday. The objective is that you will be able to identify and prove inversely and directly proportional relationships. So the word proportional, you don't have to write this down, means that different amounts are related to one another. And when I say related, I mean mathematically related. So you can see that in these two triangles, side Q and side B are related, as well as side P and A, and they're related because if you multiply the length of Q by 3, you get 3. If you multiply the length of P by 3, you get 6. And we can assume that C is also 3 times longer than R. Because these triangles are proportional to one another. They have the same shape, just that the one on the right, the sides are 3 times longer. Similar, in these two polygons, the shape on the right, its sides are 2 times longer. So if we knew this length, we could predict the length of this side. Be careful, not all numbers are proportional. So this is an amount where they are proportional. If you look at the time on the left and the distance on the right, every time you divide the time by the distance, you're going to get 1/3. Whereas over on this side, time is increasing and distance is increasing, but they're not proportional. If you divide 2 by 10, you don't get the same number as if you divide 6 by 22. They're not proportional. So again, it means they're related very specifically. So in your notes, I'm going to ask you to pause the video and write these down. I'm going to read through them. So the two proportional relationships we're going to talk about are directly proportional and inversely. The first one, directly. When two amounts have the same ratio, that's the official definition, but I think this is much easier to understand. If the independent variable increases, the dependent variable increases by the same factor. And I'm going to add one thing to this really briefly. Sorry. I'm going to get this, move to this to the side. So if they have the same ratio, if you divide the IV by the DV, you get the same number every time. Okay. Apologies for that. So as the independent variable increases, the dependent increases by the same factor. If the IV is multiplied by 2, the DV is multiplied by 2. And the independent variable decreases, the dependent decreases by the same factor. Sorry, I'll let that little thing out of the way. So the big thing is they're doing the same thing. So already we've seen that force and acceleration are directly proportional. Whatever happens to one happens to the other. So here's a graph that shows that the time is increasing, and the distance is increasing by the same factor, not by the same amount. 1 goes from 1 to 2, increasing by 1, while the distance increases by 30. But if you see, what you're really doing to both of these numbers is multiplying. So the word factor is the same in this case as it is in math. Here's another example where these are directly proportional. How much you make is proportional to the number of hours that you work. So some examples of directly proportional would be things that are directly proportional to one another. The length of the shadow and the height of the building are directly proportional. The time of a trip and the distance traveled when the speed is constant, those are directly proportional. Go ahead and write this down. Inversely proportional is going to be the opposite. So the inverse is the same as the reciprocal that you hear in math. As the independent variable increases, the dependent variable decreases by the same factor. So the key here is that one increases, the other decreases. They're doing something different. And we can prove this by multiplying the two amounts. And if you do that, you'll get the same number every time. So here's two examples. If the speed increases by 2 times as much, the time of the trip is half as much. If you go twice as fast, it's going to take you half as much time to get there. If you took 5 times as much time to get there, your speed was 1/5 of what it used to be. Not all numbers are proportional. Height and age are example. You generally get taller as you get older, but they're not proportional. When you double in age, you don't necessarily double in height. So let's look at these numbers. So first of all, we're going to kind of ignore this. Trial just means when, from every time they looked at it, what happened to it. So they looked at it at 7 different times. How did the volume change as the pressure changed? So from here, from trial 1 to trial 2, the pressure increased. Now let's see what the volume did. Well, from trial 1 to trial 2, the volume decreased. So right away, I'm thinking back to my notes and I'm seeing, okay, independent is increasing, dependent is decreasing. Let's see if that's true. Does that continue to be true all the way down? Pressure is increasing, volume is decreasing. Pressure increases, volume decreases. Pressure increases, volume decreases, all the way down to the bottom. And so the pressure has increased the whole time and the volume decreased the whole time. So looking at the data, we would assume, we can see that they're inversely proportional. We need to prove it though. So once we've looked at it, the next step is to prove the proportional relationship. All we're going to do is I'm going to make this a little smaller, and I'm going to go through and I'm just going to multiply. I use my calculator because I'm a scientist and I'm lazy. So I'm going to go through and multiply. Well, multiplying 1 by 30 just gives me 30.1. I'm going to multiply, go back to my calculator, 1.4 times 21.9 gives me 30.66. Back to my calculator, 17.7 times 1.8, 31.86. 14.6 times 2.2, 32.12. 11.8 times 2.6, 30.68. 9.8 times 3, 29.4. And last one, 3.4 times 8.8 gives me 29.29. Right? Now that I've done that, let's go back and look what it says. So it says if they are inversely proportional, the product, when you multiply the two amounts, is constant. So I multiplied pressure by volume and my product. Now, is it exactly constant? No. But is it pretty dang close? Sorry. Yes, it is. So we've proved it by multiplying and proving these are not just related, but they're inversely proportional because the product is constant. Now, again, it's anywhere from 29.29 to 32.12. They're not exactly constant. They're not exactly the same number, but for our purposes in 9th grade, that's fine enough. Let's go through this. Excuse the highlighting, you can ignore that. What happens to the shadow compared to the height? Well, first of all, I look and I see that these are just the numbers of students. So they had them all line up and they measured their height and they measured their shadow. They're not in really any particular order. So what I'm really seeing is how does the shadow change compared to the height? When I go from here, this student's height, taller height to shorter height, the shadow also goes from higher to shorter. So it's decreasing. Both are decreasing. Height decreases. Height decreases, shadow decreases. Oh, excuse me. The shadow does, oh, sorry, I said it wrong here. From student 2 to student 3, the height increased, and so did their shadow length. I apologize. From student 3 to student 4, the height decreased, the shadow decreased by quite a lot. From 4 to 5, it increased, so did the shadow height. From 5 to 6, the height increased, so did the shadow length. 6 to 7, the height decreased, so did the shadow length. And once I move my mouse out of the way, you can see from student 7 to student 8, the height increased and the shadow increased as well. Now, they're doing the same thing. So if I flip back in my notes, that means they are directly proportional. And so now these are directly proportional. So now instead of multiplying to prove, I'm going to divide. And I'm going to ask you to do that and prove it in your notes that you have. I'm going to ask you to go ahead and complete that worksheet that I passed out to you and gave you to watch with this video. Please get that done and get it back to me. That is really important to make sure you understand what's happening for this lab. Please let me know if you have any questions if you're confused.